Before we jump into any of our new stuff, we're going to do a basic review. This curriculum instantly has a review as worksheet 1C, so it's your third worksheet in your book. That is a systematic review, and so we're going to take some time today to review those problems. You either need to have that worksheet in front of you that you can take some notes on and work the problems and be able to keep so you can reference back to that, or get a spiral or some notebook paper that you can take some notes on. And let's jump into this. So we're not going to work every problem. We're going to just pick a few right now to look at, and then kind of pull out other things as we need to. So the first two I want to look at are number 9 and 10. And I want to look at some differences when parentheses are involved. So what we have here is negative 14 squared. And what you need to understand is that an exponent only works with what is directly in front of it. So directly in front of this exponent is the number 14. This negative is a separate entity. So technically what we have is negative 14 times 14. The negative itself is not being squared. So it's negative 14 times 14, which becomes negative 196. However, on number 10, we have a set of parentheses. And what those parentheses do is it sort of sticks everything together that's inside of the parentheses. So now negative 15 is one unit. Whereas in that first one, the negative was a separate unit or a separate entity of the 14. It is now stuck to the 15 in number 10. So when there's a set of parentheses, what we have is everything inside of those parentheses is being squared. So instead of being negative 15 times 15, what you have is negative 15 times negative 15, because the parentheses are together, or stick everything together. And then negative times a negative is a positive. 15 times 15 is 225. So when it comes to exponents, just watch if there is a set of parentheses or if there's not a set of parentheses, because everything inside of the parentheses becomes one unit and it has to be squared all together or cubed or whatever's happening to it. All right, 12 through 14 is solving for x. Now, this review has them written as decimals, it has them written as fractions, it has them written as whole numbers and all sorts of things. And in truth, there is a way that you can eliminate decimals in solving for x in equations. There's a way you can eliminate fractions. However, we're not going to do it that way right now. We will talk about some of those as we get into using substitution and elimination and things. But especially since we have access to calculators, we're going to just solve them using the basic steps. And those basic steps are, number 1, you want to do any distributive property that you can and add any like terms. Your second step is you're going to move anything with an x term, to one side. We like to move things to the left. Our brain processes x equals something better than something equals x. So typically we move our x's to the left side, and then our non-x terms will move to the other side. So if x's are on the left, no x's will be on the right. At that point, you want to add any like terms again, and then you will divide or multiply. And how I know the difference is if I have something times x, when I move it, the inverse happens and it becomes division. If I have something divided by x, or something x divided by something, then I move it and multiply. 99% of the time, your fourth step will be to divide. So let's just walk through one of these. Let's do number 12. And you're given 1.1 minus blah, 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 blah. Now, the directions say x, correct? But in this textbook, they use all different letters. Typically, Algebra 1, Algebra 2, trigonometry, they use x, y, and z. When you get into calculus and things, it'll almost always be x, y, or z, which is why we usually say x terms. When you're dealing with linear items, it's normally on the x axis. And anyway, it doesn't matter what the letter is, just know variable. The first thing I'm going to do is look at my steps here. There's no distributive property, so I'm going to add any like terms. And we have to remember that whole numbers or terms with no letters or no variables are the same type of thing. So I can add or subtract here 1.1 minus that, and that gives me 1.014 equals 2.4b. Now, I have all of my x terms are already on one side, my non-x terms on the other side, so I can skip that. There's no more like terms, I can skip that, and I can go to number 4. Now, how do I know if I multiply or divide? Well, I need to look right here. What is happening with my number and my unknown? And you're going to hear me say this over and over. Two things side by side with no sign means multiply. So because I have 2.4b, they're side by side, there's no sign between them, so I'm multiplying. And what I need to do, this last step, is always what's called the inverse. Whatever is happening here, I'm going to move it over here and do the inverse. Inverse is a math word for opposite. So I'm going to do 1.014 divided by 2.4, and that gives me 0.4225. The typical rule when it comes to this level of math is if you start with decimals, you want to have your answer in a decimal form. Other than that, you almost always want to leave your answers as fractions. Again, if you start with decimals, leave your answer as decimals. And the typical rule is you want to round your answer to 2 decimal places. So 0.4225 rounds to 0.42, and that's number 12 on your worksheet. Now, number 15 and 16 is factoring out the common term. And this should have been covered pretty well in Algebra 1. Sometimes you even start this in pre-algebra. So here are the steps. Now, in my world, we say tree out each term. The real wording there should be break each term into its prime factors. And then we're going to pull out whatever matches, and we're going to leave the leftovers. So let's walk through what that actually looks like. So let's look at number 15. I'm given 12a squared minus 6ab. What I'm going to do is I'm going to sort of pull this apart. This is the inverse operation, or the opposite of distributive property. So we're going to break it apart. Step 1, I'm going to tree out each term. Okay, so remember when I'm going to, or break each term into its prime factors. 12 can break into 4 and 3. You could also break into 2 and 6. Either set will get you to the same complete endpoints. And then 6 can break down into 2 and 3. So remember prime factoring? Now, because I've already typed all of this up, I need to erase the trees there. When I break this into prime factors, I end up with 12a squared becomes 2, 2, 3. When I'm dealing with variables and exponents and I spread it all out, or I break it to its prime factors, or I tree it out, I'm going to spread those letters out. So instead of writing a squared, that 2 tells me there's 2 a's, so I'm going to spread those out. My second term is minus, and then we just looked a second ago that 6 is 2 times 3, and then a times b. So for greatest common factor, we need to pull out what matches. So what I'm going to do is I'm going to circle in every term here what matches. I have a 2 that matches, I have a 3 that matches, and I have an a that matches. I have a 2, I have a 3, and I have an a. If I were to have 3 terms here, then all 3 terms would have to have that. And this becomes 6a. Whenever you have 2 sets of something, they multiply together. That is what I'm going to pull out of each term. Then I'm going to look and see what I have left over. Well, I have a 2 here. I have an a not used up. Minus, and I have a b here not used up. Those are my leftovers. So my answer is going to be what matches out front, my leftovers inside. So out front I'm going to have my 6a. On the inside I'm going to have 2a minus, there should not be a 3 there, minus b. All right, so tree everything, pull out what matches, leave the leftovers. Let's go ahead and look at 16 as well, because it has 3 terms here. And if I were to tree this 15, I'm going to do it and then I'll erase it. I'll have 3 times 5. That's a terrible 5. 18, 3 and 6. I could also use 2 and 9. 6 is 2 and 3. And 21 is 7 and 3. So I'm going to tree everything out, but instead of doing it like that, because I've already typed this up, I should have left some space. We're going to write this out. So 15ab3 becomes 3 times 5, a, and then b. Remember, spread out those letters. And then I have my plus 18, there it is spread out. And then I have minus 21, there it is spread out. So now I'm going to circle what matches. So let me come in here and see. And it doesn't matter where they are within each level here. I can sort of crisscross. So they have a 3 that matches. And they have a B that matches. Now the first 2 terms have an A, but when you have multiple terms, it has to be in all of them. Okay, so just because 1 and 2 have an A, the third one does not, so that's not a common term. So we're going to pull out what matches. We're going to leave the leftovers. So here are going to be my leftovers. We are going to have a 5 left, an A left, 2 B's. We have a 2, we have a 3, we have an A, we have a 7 and a B, and don't lose these signs here, okay? So when I write my answer, whatever matches comes out front, 3B. The leftovers go on the inside, and that first term has BB. We're going to rewrite that with its exponent, so B squared. All right, so hopefully you remember those. 17 and 18 is distributive property, and you need to be pretty proficient at distributive property. We use it so much in Algebra 1, Algebra 2. The concept of distributive property is pretty simple. You just simply multiply the outside term to all terms inside the parentheses. One thing you have to remember is the coefficients, and that's just the big numbers in the front of the term. You multiply those. But when it comes to exponents, we add them. Multiply big numbers, add exponents. Okay? So let's look at number 17. You have a term on the outside of the parentheses and you have a term on the inside of the parentheses. And what you have to do is just take this negative 13. Make sure that when you have something outside that you pay attention to the sign, because that negative is with the 13. So it's negative 13 times x squared, negative 13 times negative 2x, negative 13 times positive 4. So negative 13 times x squared, negative 13x squared, negative 13 times negative 2, positive 26. Negative 13 times 4 is negative 52, and that is it. The only thing that you might have to at some point do is if you have any like terms inside of your parentheses, like if you had something in here that was a like term, you could add those like terms first, which makes sense because order of operations, you do parentheses first. Okay, let's look at number 18. X squared, we're going to do x squared times xy. And don't forget when you have variables like this that there's an understood one exponent. I have one x there, I have one y there. I'm not going to write those exponents, they're just understood to be there. So you have x squared times xy, x squared times x3. And remember with exponents, we add like bases. So x squared and x. I'm going to add my 2 plus my understood 1. And then my x squared times x3, I'm going to add my 2 and my 3. So x squared times xy is going to give me x3y, and then x2 and x3 is going to give me x5. So there's a lot of words. Don't get bogged down in it. Just put them all together, okay? Anything that matches, put together. 19 and 20 deal with order of operations, which is another concept that you should be very proficient with. And the steps are, you do your parentheses first, then you do any exponents or roots, square roots, and that's second step. Then you're going to multiply and divide. But here's the thing, multiplication doesn't always come first. You're going to multiply together from left to right, whatever comes first. That's one step. So if I have division written first, I have to divide first. Same thing for add or subtract. Now you start order of operations very early in mathematics, so hopefully this is not new. And it starts off with a pretty basic problem of order of operations. Now one thing that it does sort of jump into is this right here, which is absolute value. Absolute value technically is how far something is away from the origin on a number line. Here's what you need to know. Solve inside, then make it the positive answer. Okay, so in here we're going to do our parentheses first, but inside of the parentheses we have to follow our order of operations. So what we're going to do first is we're going to do our exponents and roots first. So this, and this. Let me kind of clean up this green. Okay. And then we have 8 squared is 64, 9 squared is 100, 9 squared is 81, 10 squared is 100. Now within our order of operations, we're going to multiply and divide together from left to right. So here's my first division. I actually went ahead and did this while I was doing my parentheses. So 64 divided by 2 is 34. Nope. 64 divided by 2 is 32. 81 minus 100 is 19. So in order of operations, when you have a absolute value, it's just how far it is from the origin. Instead of stopping and processing all of that, just know that you solve it and then it becomes the positive version of that answer. So I'm going to solve my absolute value there, and I'm going to go ahead and do 32 divided by 4, which is 8. My absolute value of negative 19 is just 19. I'm going to continue solving in my parentheses, so 15 minus 6, then 9 plus 8, then 17 times 19, and I get 323. So that's the first thing I want you guys to look at for this week's lessons. And we'll do another concept in the next video.